back to our second session of the International Forensic Odontology e-poster competition 2020. Many of you were with us during the inauguration and even before that, but for those who didn't, again, I would like to say a heartfelt, warm welcome to all our distinguished guests for today, the participants, and the honorable jury members. This poster competition is a venture of the Innovative Pedagogical Learning team to enhance and cultivate ideas for research and innovations in the field of forensic odontology. We don't want to stop here. We want to take this forward and increase international collaborations between good ideas so as to help in the delivering of justice, which is the role of forensic odontologists. Uh, again, a repetition since some people were not there. This IPL event is being organized under the aegis of INPEFO and in partnership with AFOHR and SPOLFOC. Thank you very much for this collaboration. We are very honored to have amongst us, again, a very experienced team and a well-known team of jury members for this afternoon session. Our first judge is Dr. Emilio Nuzulio. He is the president of the AFOHR Society. He's a forensic odontologist, a researcher in legal medicine, and a professor of forensic odontology at the University of Turin, Italy. It's great to have you amongst us. We've had a personal association with him over the years, and it's really nice to see you at all our events. Thank you for your constant support. Our second judge today is Professor Ivana Bajic, but she somehow has not been able to make it today. But we have Dr. Ivan Bedic. He's a researcher and scientist specialized in the field of forensic odontology. He has done his PhD from the School of Dental Medicine, University of Zagreb, and he's even written a book on the new and innovative models of dental age estimation among children. It's so good to have you amongst us. We welcome you to this competition. Our third judge today is Dr. Abraham Johnson. He's the program coordinator at the International Center for Humanitarian Forensics and also an assistant professor at the School of Forensic Science, National Forensic Science University, Gujarat, India. Very Johnson, we look forward to having more of these interactions. Now, before we actually begin with our student presentations for session 2, I would like to request Dr. Ivan Bedic to kindly announce the results of the faculty session, which was held in the morning.
Before Dr. Ivan announces the results, I would just take 1 minute to tell that the first session was really a stimulating session with all the original research and the innovations that have been presented by the presenters. And they were judged by our esteemed 3 judges, Dr. Goria, Dr. Wendy, and Dr. Hemlata. And they were judged on the basis of innovation, clarity of idea, ability, presentation, and content. And while marking them, it was really so difficult for the judges and for us to compile the results. You were really so close. So we've kind of rounded off with a difference of 5 marks. We've rounded off and we have culminated the results, which Dr. Ivan would be presenting in just a few seconds. So thank you all for a wonderful participation and congratulations to all the participants and the winners. Dr. Ivan, over to you.
Thank you. I will start with the third place, which 2 posters achieved. So the first one is from named Forensic Application of EDXRF to identify the gender from saliva and urine from Dr. Joshi. And the second one, Cold Laser Oral Therapeutic Device by Dr. Chawla. That's the third place. Then the second place is Dr. Francesca Zangari, an original proposal in dental data collection and keeping to enhance human identification. And also second place by Dr. Temgich, modified caligostain, its research applications in forensic odontology. And the first prize goes to Dr. Anshul Chaudhry with poster named Simplicity in Application of Dental Age Estimation Chart by Dental Interns. Congratulations.
Congratulations, everyone.
Congratulations to all.
Many, many congratulations to all.
I must tell you that we have 150 posters, and out of that, it's really honor to have so many good entries. And I hope you go through the souvenir which is circulated. If not, you can ask on email from us. We will be sending it to you. We proceed?
Yeah. So great. Congratulations to all the winners and to all the participants. And I think we should start with the student session now. The first poster in the student category is PS103. The poster ID is PS103. It's going to be presented by Nisha S. And she's going to be talking about the demographic variation in tooth morphology. PS103.
Nisha?
Good afternoon, everyone.
Yes.
Shall I start screen scan?
Yes, please share your screen. Your time will start now, so please stick to the time.
Yes. Yes, ma'am.
Yeah.
Good morning to all and all gathered here. My poster ID is PS103, student category. The topic which I am going to deal with today is demographic variation in tooth morphology. Moving into my topic, first saying what is demographic? It is a study of population based on factors such as age, race, and sex. What is demographic data? It is a statistical data collected about the characteristic of the population, example, age, gender, race, ethnicity, geographic area, and income level. Variation in tooth morphology defines as valuable for understanding variation among species and adds information for phylogenetic and genetic studies. The main aim of me to take this topic, demographic variation in tooth morphology, is it is useful for correlating and distinguishing people as there is varying degree of expression of dental features. And this is a candlestick data which shows the country names along with the percentage. And now moving on to ethnic origin. First, we will deal with Cascodes. The most common feature of Cascodes are they have chisel-shaped incisor, small, and have smooth lingual surface. Their lateral incisor are usually peg-shaped. The cusp of carabulae is most common notable features of them. And they have narrow V-shaped arches giving rise to crowding of teeth. All molars shows the great frequency of bent and slanted root. And moving on to Mangaloyds, their characteristic features are they have double shovel-shaped incisor, absence of cusp of carabulae, elonged premolars and oriented premolars, and in this condition it is called dense invaginatus. Their dental arches have a parabolic arch with large incisor, canine, small premolars, and large molars behind them. Negroids, they have extension of supernumerary teeth with small and spacing of midline diastema. Their third molars are always present and rarely impacted. The presence of cusp of carabulae and shovel-shaped incisor is uncommon. And finally, moving to osteoids, they have shovel-shaped incisor. Mesial drift of teeth is a noticeable feature. The dental arch is usually large, naturally accommodate large teeth. Midline diastema is usually present. Reduction of incisal gingival length of the teeth resulting in spaculated teeth. The cusp of carabulae is usually absent. Tooth coloring and tooth decoration. So the teeth blackening are performed in most people like Borneo and Indian people of southern Peru. And tooth dyeing are performed in Vietnam, Laos, Thailand, Indonesia, and Philippines. Red staining is common in Morocco. It is the consequence of chewing mohora fruit by the people. And in ancient Mexican, used as precious stones as their inlay in their teeth. And moving on to avulsion and extraction, most of the people do this. Avulsion of incisor still abundant among the people of South Africa, especially to the low socioeconomic families. Tooth extraction is common in African tribes, but it is mainly in the custom of Kenya, Tanzania, and Sudan. The villages of South Saharan region extract their lower incisor after eruption as a rite of passage to enhance their beauty, to show their tribal identity, and even to allow the emission of specific linguistic sound which they pronounce. And in some Australian tribes, tooth ablation has been rite of passage and or the signs of monitoring, the very common practice. Occupational variation like abrasion found among the cement and sand workers, grinders, and stone cutters and miners. The greenish stain on the teeth are due to inhalation of nickel dust and copper dust. Black line on the teeth on the workers of iron millings. Yellow or gold brown stain while working in the nickel cadmium battery factories, electrical industry, engines, aircraft engines, and marine engines. And moving on as to determine the ethnicity, the dental characteristic features such as shoveling or looping of the upper incisor, toroodontism, chisel-shaped incisor, carabinate cusp, hypocones, prostostyles, and the peg shaping of the teeth can be used to determine the ethnicity of the individual, like showing in the picture which demonstrate everything. And filling and morphological modifications also mostly present in Cameroon, Congo, Guinea, Zari, and Uganda. The teeth are shaped to resemble those of crocodile. And in some South American Indian Valley, Amazon Valley, modify their central incisor to the sharp shape, which imitating the piranha fish. And in Tanzania, the upper and lower incisor enamel is chipped off so that the teeth appears as a peg-shaped. And among Java, Sumatra, and Borneo groups, the incisor are thinned and shortened, which this diagram shows us how it is a man-made thing. And my conclusion with forensic consideration is, forensic odontology plays a relevant role in the identification of the unknown individual, but we are in the position to store the identified statistical data based on the factors such as geographic area, age, race, and gender. This is review and attempt to summarize. This review is to attempt to summarize the possible consideration in determining the race, occupation, and ethnic background from the teeth for the identification of individual. Thank you so much for giving me this opportunity.
Thank you. Very well presented. I would like to request the judges if they have any questions.
Yes.
Any specific distinctions you have found in terms of nationalities beyond ethnicity?
Can you repeat it, please?
I mean, beyond the distinctions of ethnicity, do you feel there are some differences also in terms of nationalities or not?
Nationalities.
I mean, like Italian, Americans, British,
Yes.
people living in these countries. Do you feel that there are any distinctions in terms of tooth morphology?
Yes.
Maybe yes, maybe not.
Yeah. Yes, maybe.
Okay. Thank you.
Thank you.
Very well presented. Thank you.
Thank you.
Dr. Nisha,
Any other question?
I have a question. How can you relate this topic with forensics? Like, do you think the tooth morphology can be used in reconstructive identification, or it can be used in a comparative identification?
So I think it is mostly in comparative, like because I'm dealing with the tooth morphology and I'm comparing that with every origin, like how it is resembles the same, so that the person can identify easily that person, like identity can be seen.
Okay, thank you.
Thank you, Isha. Moving on to the next presentation. The next student presentation today is PS106, Dr. Anju Maria Thomas, and her title is The Investigation of Sexual Dimorphism Using Geomorphometric Analysis, an Indian Study. PS106.
Can't see PS106.
Yeah, I'm just sharing my screen.
Oh, just a moment. Don't start. Okay, please go ahead.
Is my screen visible?
Your voice is cracking.
Your screen is visible.
Hello.
Your voice is a little shaky. The internet probably.
Oh, okay.
Just switch off your video sharing. Don't share the video, because I think you're taking too much of bandwidth.
Yeah, okay. Yeah, I'll do that.
Stop your video. Yeah, please go ahead now. Share your screen now. Share your screen.
Yeah, is it visible now?
Yes,
Hello?
yes, it is.
Yeah. Good morning and a warm welcome to all present here. Today, I will be presenting on investigation of sexual dimorphism using geomorphometric analysis. This was an Indian study which was done. So, as we all know, human identification is one of the core aspects of forensic science, and sex determination is a matter of great importance.
Kindly make it full screen, madam. Please make it full screen.
Yes. Is it full screen? Hello?
Yes, it's full screen. Please continue.
Yeah. Sorry for the interruption. So, as I mentioned, for sexual dimorphism is more precise when complete skeleton is available. But such a scenario is very difficult to be obtained, especially when we see the cases of mass disaster and crimes. Now, here we have chosen mandible. Now, the peculiarities of human mandible are it represents the greatest morphological changes in size during growth, especially in the mandibular, condylar, and ramus region. So, the objective of our study is to focus on sexual dimorphism in Indian population using geomorphometrics, and thus creating a robust method for the identification of sexual dimorphism. Now, when we come across traditional morphometric methods which are used to determine sexual dimorphism, these are mainly based on manual tracings, and these mainly focuses on linear and angular measurements. So in such cases, these tracings are limited to landmarks and straight lines, and they fail to discrete the changes of curve, shape, and growth, and display the displacement of vector rather than generalized distortion. So in order to overcome this, we can use a geomorphometric approach. Geomorphometric analysis is a statistical analysis of shape and form based on Cartesian landmark coordinates, and involves placement of homologous landmarks on specific locations. And these locations would be having either some structural, functional, or developmental significance. Now, coming to our study, the materials which we used, we collected a sample of a total of 149 digital OPG images, out of which 75 of them were male and 74 of them were female. And the age group which we took for the study was between 18 to 50 years of age. Now, we included the following samples: radiographs with complete natural dentition. And under exclusion criteria, we included under exclusion criteria, the distorted OPG with pathology, any jaw discrepancy or malocclusion were excluded from our study. Now, these OPGs were then digitized using TPS-DIC software and then TPS-UTIL software for analysis. Now, in this software, 3 type 1 and type 3 two-dimensional landmarks were digitized along the symphysis and condylar region using the TPS software, and then 50 resampled equidistant sliding semi-landmarks were positioned along the inferior border of the corpus and the posterior border of the ascending ramus. And then semi-landmarks were anchored anteriorly and posteriorly to fixed homologous points. Now, as I mentioned about the landmarks, so these are the landmarks which we selected for our study. Landmark number 1 was infradental point. Landmark number 2 was most posterior point on the mandibular condyle. Landmark number 3 was most anterior point on the mandibular condyle. Then coming to some landmarks, that was landmark from 4 to 33. They were equidistant semi-landmark series, which were captured along the inferior border of the mandibular corpus from gnathian to gonian. Then coming to landmark number 34 to 53, they were equidistant semi-landmark series captured along the posterior border of the ascending ramus from mandibular condyle. Now, after the landmarks were marked, the digitized samples were then analyzed in the Morphology software. So the following steps were undertaken. Initially, partial Procussive superimposition was done. So it enabled the translation and rotation and scaling of the landmarks. So in this stage, it provides a reference for the shape changes and centroid size and shape independent size measurement. Then we included classifiers to the data set, which was then projected into the principal component analysis. After that, after adding classifiers, then we moved to the principal component analysis. It was performed in order to reduce the dimensionality and also to investigate the patterns of population variation, and also to test for significance of shape differences between the two groups using Procussive's Anova. Finally, we performed Fisher's discriminant analysis to assess the accuracy of the classification. Now, coming to the result part, as we can see, the initial 10 principal component accounted for about 96% of the shape variation in the sample, and with first 8 PCs accounted for about 95% of the cumulative shape variation. What we need to see is the first 3 principal component itself showed a total of 72.59% of shape variation in the sample. So as we can see below in the graph, PC1, PC2, PC3, the shape variation, they were primarily manifested in the following areas, that is the height of the ascending ramus, the gonial angle, and also along the inferior corpus region. Now, as I mentioned, we had performed the discriminant analysis. The discriminant analysis, it effectively identified 89% of the people by biological sex. And then it correctly identified 96% of the sample as males and 89% of the samples as females. Now, the p-value which we got was below 0.0001, which also indicates that the study was statistically significant. Now, this is the table which we got while performing the discriminant analysis. It shows the correct prediction of male and female. So male was correctly predicted by 90.6% and females were correctly predicted by 89%. Now, I would like to conclude that this approach can be very well used to determine the sexual dimorphism in dentate mandible, and also the results which we have obtained in this study provides an insight to the usefulness of OPG for sexual dimorphism in dentate mandible. So the new and robust technique of geomorphometric analysis can be very well used to determine sexual dimorphism. Furthermore, in order to increase the predictive value of this study, we can increase the number of samples, and thus we can furthermore increase the predictive value of this approach. Thank you so much.
Can you stop sharing, please?
Yeah.
Yeah.
Thank you. Very well presented. Good study. Judges, I hand over the stage to you. Any questions?
I would like to ask you, your sample excluded the RPGs with missing teeth or malocclusions. So do you think that even those with malocclusion and missing teeth would be suitable for this kind of analysis? And would you get the same results?
So we wanted to conduct this study for first considering the ideal population, because this was the first study which was conducted in India. So first we wanted to begin with only considering the ideal condition, that is including only including natural dentition and all the malocclusion.
Thank you. You're right. Everybody does that first. Very well.
Thank you.
Anything else? Okay.
I would like to propose to the colleague to a joint international idea of widening the samples, because this is something we have been studying on Italian sample as well. I presented a very, very similar research using morphometric analysis and achieving the sexual dimorphism through the gonion, through the angle of the mandible. So I think that it would be interesting to assess if there is any kind of distance and differences among ethnic groups, or if we can globally assess sex from the gonion of the mandible using this technique. So if Professor Chaudhry is also agrees and the team agrees, I would like to take this chance to propose to the students a joint research on this topic with the goal of widening the sample. Thank you.
Excellent, excellent. It can be multicentric. The PS 106 only suggestion to your humble submission to your poster will be that please check your bandwidth next time you enter the virtual world. I know it is very tough for us to really comprehend what you're speaking, but excellent presentation nevertheless. And Dr. Emilio, we'll consider, we have been on various platforms, we'll be doing it, you know it, we'll pursue it.
Moving forward, the next third presentation today is PS 109, Dr. Arul Vizi M. And the title of the presentation is Assessing the Accuracy of Demergence, Acharya and Williams Method for Age Estimation for Kerala Sample Population. PS 109.
Am I audible now? Hello? Hello?
Yeah. We cannot see your video.
Am I audible now, ma'am?
Yes, you're audible, but your volume is very low. If you could somehow adjust the mic settings. Or speak a little louder, probably.
Am I audible now?
Yes, now it's fine.
Okay, okay.
Yeah, please share your screen.
Can you see now?
Yes,
Okay, okay.
please start.
So, a very good afternoon to one and all present here. Today, I'm here to present my poster on a study in assessing the accuracy of Dimajian's, Acharya's, and Willem's method of age estimation for Kerala sample population. So, moving on to the topic, and age and death estimation is important component of both archaeological and forensic studies of skeletal remains. And application of dental knowledge in the forensic is very useful in the criminal and civil laws and the criminal justice system, out of which human identification is one of the most important, challenging, and indispensable aspects of forensic science. Its clinical application is enormous in both situations requiring the identification of a living individual or a deceased individual. So, unavailability of the chronological age brings to the forefront the importance of age estimation for human identification. So that tooth development is widely used in determining the dental age. And this tooth development occurs in successive stages, which includes the calcification of the cusp and crown to root formation. And this sequential stages may be used for age estimation. However, uncertainty regarding the best method of age estimation still persists. And this study was done to assess the accuracy of 3 dental age estimation methods, that is Dimajian's, Acharya's, and Willem's methods. So, aim of my study was to compare the accuracy of 3 radiographic age estimation methods in Kerala sample population. So, for that, I used 100 digital orthopantogramic images of subjects age ranged between 7 to 23 years. Those who reported to the Department of Oral Medicine and Radiology in our institution. And dental age of the subjects was determined through Dimajian's, Acharya's, and Willem's method. Differences and correlation between the chronological and dental ages were assessed using paired t-test and Pearson's correlation analysis. So, moving on to my inclusion criteria, I included subjects whose all mandibular teeth were present, either erupted or unerupted, and the subjects should be physically healthy, well nourished, and they should be non-syndromic, and there should be not any history of surgical or medical diseases that could affect the presence or development of the permanent teeth, and radiographs of the good diagnostic quality were included. And I excluded unclear orthopantogramic images and the patients with systemic diseases, congenital anomalies, dental abnormalities, and any permanent teeth extraction was done. That case also I excluded. And the OPGs were obtained and they were coded in order to avoid the bias during the scoring of the radiographs. And the investigator did not know the chronological age of the subject when assessing the radiographs. And this is the stages of the tooth development chart, and this chart was used to give the initial score to all the 3 methods. And then I proceeded the Dimajian's method with the Dimajian's score chart and Dimajian's maturity score, and proceeded the Willem's method with Willem's age chart, and proceeded Acharya's Indian specific method with Acharya's Indian specific regression formula. And the results were observed. And then comparing the chronological age with the all the 3 methods, we observed that there is a significant difference in the mean chronological age and estimated age in all the 3 methods, and the correlation between the chronological age and estimated age was found to be significant positive correlation. And in comparing the chronological age and estimated age in male and female also showed that there is a significant difference. So, in my present study, the Dimajian's method underestimated age with mean difference of 1.22 years. The values found obtained were significantly statistically significant, that is p-value less than 0.001. And a similar study was carried out by Javadinejad et al. In Acharya, which also showed underestimation of age. And in present study, Willem's method underestimated age with mean difference of 1.52 years. The values obtained were statistically significant with p-value less than 0.001. And similar study carried out by Rezwana et al. And Javadinejad et al. Also showed underestimation of age using the same Willem's method. And the Acharya's method also overestimated age with mean difference of 3.23 years. And the values obtained were statistically significant. And similar study was carried out by Muhammad Arbi et al., which also showed mild overestimation of age using Indian specific cubic equations. And the varied results were also published in the literature. That is, an underestimation of age in using Acharya's method has been reported by Sudha et al. In Hyderabad sample population and Gandhi and et al. In Gujarat sample population. So to conclude, the present research showed that although Dimajian's method showed the highest accuracy in estimating the age of the studied sample, Willem's and Acharya's method can still determine the age of the Kerala population with acceptable accuracy. However, present study has limited sample size, so limited conclusions can be drawn from the study. And studies with a larger population data is essential to derive at an ultimate decision. And other methods of age estimation should also be tried along with the Demergian's, Willems, and Acharya's method to confirm the accuracy. For the maturity score specific for Indian sample population need to be studied to improve the predictive accuracy of the radiographic methods. And these are my references. So thank you for this great opportunity. Thank you.
Thank you. Very well presented. Any questions?
I need you to stop sharing, Doctor.
Yes, sir.
Just a clarification on the population, because to me, Kemala population doesn't have a meaning, because I'm from Italy, not because I, with respect to you, I would like you to please specify why you chose this population and what does it represent in India, I suppose.
So this is an institutional-based study, so I was found to get only the Kerala sample population who are living in the...
Okay. I'll put the Dr. Emilio's question. The population which you're testing, how did you know that it is purely Kerala? First of all, you know, Kerala is supposed to be a state. So what kind of ethnicity you're testing?
Sir, I included the students from my college itself. So I checked all the their details about where they're coming from and about which population they're coming from.
How many generations did you check? How many generations? 2 generations, 1. Mother tongue, what did you check?
So mother tongue and also the age.
So in your presentation, it is very important to specify that ethnicity was pure, because we will be correlating it with the South Indian population, which will be mostly inclined towards the Dravidian ones, which we claim. You know, so you have to really specify what kind of a population you're looking at. I'll not go into the race part. We are not racist, but we have to, as an anthropologist, we have to specify which population target we are doing, and that's what Dr. Emilio wanted to ask you.
Just a suggestion. I saw that your sample consisted of individuals between 7 and 23 years. So the basic problem is the older individuals here. So the main age was here 15 years or more, the mean age. The limitations of Willems and Emilien's method tend to be around 16 or 17 years. So when you will investigate more and when you will widen your sample, try to widen it, but in a way that you include the younger individuals in the study rather than the older ones.
I should start. Thank you very much, sir.
I have a last question. Apart from you, anybody else had coded the samples or tested? Because whether you have gone for the inter-observer error rate?
Yes, sir. So my guide along with me coded the samples for me, and I tested the results.
Okay, so what kind of tests did you perform statistically, and what's the inter-observer error rate?
Statistically, Pearson's correlation analysis and parity test was performed, sir.
Okay, thank you.
Okay.
Right. Okay. So moving on, fourth presentation, PS111, Dr. Ayushi Arora. She'll be talking about diagonal tooth measurements in sex assessment, a study on North Indian population. PS111.
Hello.
Yes.
You can hear me?
Yes, we can hear you, right. Please make your screen full screen and then you can start.
Okay. A very good afternoon to one and all present here. My topic for today is diagonal tooth measurements in sex assessment, a study on North Indian population. This is an original study which was conducted at my institute. First of all, let's discuss about sexual dimorphism.
It refers to those differences in size, stature, and appearance between male and female that can be applied to dental identification because no two mouths are alike. In general, for sex determination studies, the mesodistal and buccolingual measurements of teeth, crown diameters, and combinations of root lengths and mandibular canine index are used. However, there is a loophole because these dimensions are affected by atresion, cervical abrasions, interproximal wear facets, crowding, presence of dental calculus, and if teeth are still held in the tooth socket, it is difficult to take measurements. So alternative dental measurements were developed. For example, crown and cervical diagonal diameters and mesodistal and buccolingual cervical diameters of teeth. So the aim of the study is to assess the degree of sexual dimorphism in teeth of a North Indian population using crown diagonal diameters and to evaluate the applicability of diagonal measurements in sex determination by means of discriminant functional analysis. So the materials and methods used are, the study sample comprised of 200 upper and lower jaw dental models belonging to 100 males and 100 females of age group 18 to 57 years. So the inclusion criteria was fully erupted teeth from right permanent central incisor to the right molar, no fillings or extractions, no crowns, crowding of teeth, fractured teeth or orthodontic apparatus, and no developmental or orthodontic anomalies were included. Third molars were excluded, and in case the right tooth is absent, dimensions of the left were taken, and in case both were absent, the cast was excluded from the study. Using these models, mesobuccal distolingual and distobuccal mesolingual measurements of 7 teeth on each jaw were taken separately using digital vernier caliper, and the measurements were performed by one person and all values were rounded to 2 decimal places. After that, intra-observer and inter-observer errors were tested, and their measurements were analyzed using students' t-test. The level of statistical significance was set at p-value less than 0.05. The mean values of mesobuccal distolingual and distobuccal mesolingual dimensions were subjected to the following formula. Percentage of sexual dimorphism, which is defined as the percent by which the tooth size of males exceed that of females, is equal to xm divided by xf minus 1 into 100, where xm is the mean male tooth dimension and xf is the mean female tooth dimension, and the data obtained was further analyzed using stepwise discriminant function statistics using SPSS version 10. The results are, a total of 28 measurements were taken on 14 teeth on each individual included in the study, 7 teeth from the upper jaw and 7 from the lower. So a total of 5,600 measurements on the teeth of 200 individuals were accomplished and analyzed using SPSS program. So there are tables 1 and 2. In the mesobuccal distolingual crown diameter, as seen in the table 1, both maxillary and mandibular central incisor, canine, first molar and second molar, showed a statistically significant difference between males and females. Percentage of sexual dimorphism was maximum for maxillary central incisor, which was 7.4%, followed by maxillary and mandibular second molar, which was 6.1%, and maxillary canine with 5.8% in mesobuccal distolingual crown diameters. And in the table 2, we can see the distobuccal mesolingual crown diameters. And for that, maxillary central incisor, maxillary and mandibular canine, first molar and second molar showed a statistically significant difference between males and females. So the percentage sexual dimorphism was maximum for maxillary central incisor again with 6.4%, followed by mandibular first molar 5.8% and mandibular second molar with 5.1% in distobuccal mesolingual crown diameters. The table 3 and 4 depict standard coefficient, structure matrix, unstandardized coefficients, raw coefficient, group centroids, and sectioning point for mesobuccal distolingual and distobuccal mesolingual crown diagonal dimensions respectively. So in the maxillary teeth, accuracy for sex determination was highest, 80%, for distobuccal mesolingual crown dimension of central incisor, and lowest, 57.5%, for distobuccal mesolingual crown dimension of first molar. And in the mandibular teeth, accuracy for sex determination was highest, 72.5%, for distobuccal mesolingual crown dimension of the first molar, and lowest, 51%, for the mesobuccal distolingual crown dimension of the central incisor. And in the table 5, we can see the results of the analysis of crown diagonal diameters and accuracy rates. So the accuracy of determination of sex by mesiobuccal distolingual crown dimension ranges from 55 to 75% in males and 47 to 84% in females, while by distobuccal mesiolingual crown dimension ranges from 55 to 80% in males and 65 to 80% in females. Now we're going to discuss on the whole topic. The dentition takes precedence, particularly when preferred parameters such as the pelvis are unavailable and cranial and long bones are fragmentary. However, since linear tooth measurements usually give moderate levels of accuracy in sex identification, alternative means of assessing sex within the realm of linear measurements needs investigation. So this study investigated whether univariate sexual dimorphism in diagonal crown diameters offered a solution. So the results obtained from crown diagonal diameters taken during the course of the study showed that diagonal crown dimensions in all teeth of males exceeded that of females, except one tooth, which was distobuccal mesiolingual crown diameter of the maxillary lateral incisor. So the percentage sexual dimorphism was maximum for the mesiobuccal distolingual crown diameter of the maxillary central incisor, followed by distobuccal mesiolingual crown diameter of the same, to 7.1% and 6.4% respectively, and minimum for distobuccal mesiolingual crown diameter of the maxillary second premolar, followed by distobuccal mesiolingual crown diameter of the maxillary first premolar, for 0.2 and 0.3% respectively. Crown diagonal diameters of both maxillary and mandibular second molars showed more dimorphism than first molars, and male molars are larger than female molars. These results were similar to the study conducted by Zoba et al., and the highest rate of accuracy was observed in distobuccal mesiolingual crown dimension of maxillary central incisor, and the overall accuracy was 51 to 80% respectively. The accuracy rates of canines and molars in diagonal measurements were not as high as that of maxillary central incisors, and this result was in contrast to the study done by Karaman, who found that canines show the highest rate of accuracy. So in the current study, accuracy rate of sex determination was higher in females than in males, and this result was in concordance with the study conducted by Karaman in Turkish population and Scan and Kadici, who observed more dimorphism in female subjects as well. On comparison of accuracy rates of determining sex among molars, it was observed that mandibular molars were more dimorphic than maxillary molars, which was again in unison with the study conducted by Zorba et al. Previous studies indicate that mesodistal and buccolingual dimensions are more accurate in determining sexual dimorphism, but in situations in which it is difficult to take correct measurements, for example, like presion, etc., so we can use alternative odontometric measurements as well. So the conclusion of the study is, it was found that mesiobuccal distolingual and distobuccal mesiolingual crown dimensions are reliable indicators and can be used along with or instead of linear measurements in sex determination. So these can be useful in archaeological, odontologic, genetic, forensic, and crime investigations as ethnicity environment are known to affect traumatic.
Any questions?
Doctor, I have a question. How did you measure the buccolingual and distobuccal kind of diameters in incisors?
The vernier caliper was held parallel to the tooth surface, and we measure the maximum distance from
which was the surface, whether you took the facial surface, the lingual surface, or the incisal surface?
So it was the crown basically, and it was held parallel to the occlusal surface.
Okay, because I don't see any kind of mesiobuccal cusp in incisor. We can definitely do a kind of a diagonal measurements on molars, but I'm not very sure with the anterior teeth. Okay, thank you.
Right. Our next presentation today is by Dr. Pooja Chakrabarti. Her poster ID is PS112. And she'll be talking about dental bioarchaeology, the tales teeth tells. PS112.
Am I audible, ma'am?
Yeah, you're audible, but we can't see you.
I think it's the lights problem, ma'am. The video is on though.
No, 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 it's absolutely black. So it's not the light. There is some camera issue. Okay, maybe you could just share your screen and
Yes, yes, ma'am.
yes, now we can see a little bit of you.
Is my screen visible?
Yes,
Thank you.
right.
A very good morning to one and all present here. The topic for my presentation is Dental Bioarchaeology, Deep Tell Tales. This is a review poster. General archaeology is the study of human history through materials, artifacts that are unearthed or discovered. When human remains are uncovered at an archaeological site, their study falls under a subject known as bioarchaeology. This form of archaeology was originally named in 1972 by Graham Clark. Initially, bioarchaeology was more like a type of zooarchaeology, primarily focused in studying the animal remains. But the archaeological study of human remains became known several years later due to Jane Allen Registra. Studying the bones and teeth of humans who have lived and died in the past provides a wealth of information for scientists. These skeletal remains can tell the health, age, and gender of an individual. Through dental bioarchaeology or the study of the teeth of humans, even more information can be discovered about the individual and about the area being researched. A person's teeth and bones are what remain after their bodies have long gone since decomposition. And in some cases, the teeth may outlast bones and be the only part of the body that remains. Like bones, dental remains can reveal the health of the individual and they can also reveal the details about a person's diet. Now, coming to the various aspects of this subject, though I have given separate headings, but let me tell you that they are all kind of interrelated. Paleogenomics is a nascent field that studies DNA in remnants of ancient teeth. DNA in teeth is well protected from most of the taxonomic and microbial changes. Dental calculus is also of great help in this respect to explore broad aspects. High throughput DNA sequencing of calculus has provided valuable insights into the evolution of oral microbiome and the history of epidemics. Sticky plaque entraps everything in our mouth, and fortunately for the paleogenomic researchers, biomolecules such as DNA remain preserved in our teeth for millennia. This rich source of biomolecule offers a detailed record of pathogens activity, evolution, allowing common diseases in our past and present to be better understood. The molars and premolars are of high value with this respect because of their position and volume of the pulp chamber. Dental modification or jewelry. Dental modification is performed for different cultural purposes. In modern days, we have the orthodontics. In past, it was filing down teeth to points, grills, stone, beads, etc. Teeth can also be unintentionally modified by certain habits, such as smoking a clay stemmed pipe or using teeth as a tool. This similar culture can still be witnessed in certain parts of India where women uses beads to decorate their teeth. If history is to be believed, Egyptians used gold dentures to protect their teeth. In America, the dental grills were used by two different societies with two different meanings. On one hand, it was a sign of freedom, and on the other, the pop stars sported as a sign of a style statement. The females of the Mayan culture stained their teeth in black to de-beautify themselves and protect themselves from the invasion of other groups. Coming to age and ancestry, metrics and non-metric features can help us determine the ancestry of the remains. We have a software called R-Asudas and the Asudas block, which can help analyze non-metric trait. To determine the age at the time of death, any standard radiographic or histologic method or the eruption pattern can be used. But yes, the first priority will be not to destroy the historic piece of evidence. For the age since death, various dating methods like stable isotope analysis, carbon dating, N14 uranium series, ash analysis in cases of incinerated remains can be done. Teeth as tools. This mainly includes the activity-induced dental modification. Each one of us have certainly used teeth as our third hand at times, but the same aspect, when analyzed on the ancient samples, reveals surprising facts. Studies of grooves and striations have led to consensus that toothpick may be one of the earliest tools devised by humans. Talking specifically about the Baikal case study, grooves on the occlusal surfaces observed were most likely produced during the processing of fibers from plants and animals for making items such as nets and cordages. Teeth as an evidence to epidemics. The growing evidence suggests that the first epidemic forced societies to make epoch-defining transformations. For some infectious diseases like the syphilis, tuberculosis, leprosy, the location and characteristic distribution mark on a skeletal bones and teeth can serve as distinctive pathonomic indicators of the infection. The archaeological and historical records are reminders that people have lived with infection diseases for millennia. Some diseases never leave a mark at all, including that of plaque and viral infections like HIV and the diseases that kills quickly. In that case, analyzing the soil can be of some help and genetic analysis can be of great help in this case. With COVID-19 pandemic this year, it won't be surprising if it starts showing some effects on the skeletal parts too. And there have been reports of alveolar bone changes with respect to COVID-19. History of migration. Strontian level analysis done from bone and teeth when compared to the strontian levels of the soil reveal the area of migration. But for that, a database of the land is a must-have. Coming to the dietary patterns. Diet plays an important role in the organization and evolution of human cultures, and a diverse array of analytical techniques are available to help reconstruct diet in ancient population. Dental paleopathology is particularly important as it can provide direct evidence of the type of diet an individual consumed during life. Heavy occlusion footwear is one of the most frequent findings, and an examination of both macro and microscopic patterns of wear can establish differences between the hard fibrous diet typical of a hunter-gatherer and a diet primarily consisting of a softer plant food consumed by an agriculturalist. The distributions of trace elements and stable isotopes in food webs make it possible to use them as a natural tracers of food stuff. Through a consideration of the photosynthetic pathways, the ratios of different stable isotopes of carbon and nitrogen can determine which specific group of plant and animals were dominant in the food web. Evolution of teeth and history of dentistry. New species of ancient human discovered in Philippines, dubbed as Homo luzonensis, were identified from a total of 7 teeth and 6 small bones. Coming to the history of dentistry, earlier denture teeth were made of real human teeth. Gold was drilled into canals filling. Various types of waxes were then used as a restorative agent. The demerits of this kind of a study is that paleodemography is possible only when a good number of samples are retrieved, which is not the case always. So, to give an opinion based on a limited number of samples is a challenging task, and retrieval of those samples is again a mammoth task given modern day construction hampers its stay. Like Anubiri's skull samples were found while digging up the construction for drainages. To conclude this, in India, we already have an overburden of cases over the judiciary system. With the knowledge of dental bioarchaeology, at least the cases that are more than 90 years old can be given to the bioarchaeologist to extract data. This is a budding stream and has a good scope as long as understanding the past is important in the future. It becomes a very hectic task to reconstruct the past when there is paucity of evidence of that era. Newer methods like radiocarbon dating, uranium dating are not only specific, dynamic, but even a very reliable source of data analysis. With this, I would like to rest my presentation. Thank you. Should I stop sharing the screen now?
Yes, yes. Thank you, Pooja. Very well presented. Any questions? Okay.
Anything from the judges? Okay.
Our next presentation, the 6th presentation for today, is PS 115, Dr. Shraddha Singh, and she'll be talking about geometric morphometric analysis for sex determination using laterocephalograms in an Indian population. PS 115. We can't see your video. Okay, yes, we can.
Is my screen visible, ma'am?
Yes,
And
yes, we can.
I'm audible. Am I audible?
Absolutely. Please start.
A very good afternoon to all the jury members, seniors, and my dear colleagues. Thomson D.W. in 1917, in his work on growth and form, beautifully stated, "The harmony of the world is made manifest in form and number, and the heart and soul and all the poetry of natural philosophy are embodied in the concept of mathematical beauty." I now hereby introduce you to my topic for today, which is geometric morphometric analysis for sex determination using lateral cephalogram in Indian population. As forensic odontologists, we all know that identification is the whole soul in forensic odontology, and gender determination is one of its most important pillars. Of all the skeletal bones present, skull marks the most prominent one when we talk about gender determination. Also, the skull has been known for its accuracy of around 80 to 100% when we talk about classifying the gender. Lateral cephalogram is one of that kind of easily available radiograph of this skeletal aspect, which has been used in lots of studies in the past. In past, a lot of traditional morphometric measures and a lot of several metric analysis has been used in gender determination. What they tend to use to be done was they use landmarks, straight line, angles, and ratios in order to calibrate the gender differences. This novel method of geometric morphometric analysis, which is a mathematical shape study, focuses on Cartesian landmark coordinate for a particular areas of relevance, and called structural, functional, and developmental relevance. They tend to differentiate the shape, removing the non-shape variation, which is very important because they tend to undertake any kind of distortion and also arc and shapeal variations, which are often either undermined or underlooked in the traditional morphometric measures. The objective of our study is the research paper tends to focus on assessment of sexual dimorphism in class 1 malocclusion using geometric morphometric analysis and creation of a rigorous framework for the identification of sexual dimorphism. In order to carry this objective forward, we collected 105 lateral cephalogram, of which 54 were males and 51 were female, of age group 18 to 50 years. Inclusion criteria embraced complete permanent dentition without we did not consider the third molar in case of any dental parameters. Exclusion criteria were dental ergogenesis was excluded except for the third molars, cleft palate, craniofacial syndrome, former orthodontic treatment, prosthetic therapy. Basically, any morphological or pathological changes or any aberrations, any deformities were excluded from it. We try to keep it as ideal as possible. We selected 9 anatomical landmarks, which were very significant landmarks, and these landmarks were fed into TPS util and TPS 2.0 software, where these landmarks on the lateral set were digitized. Once we got the digitized data, we fed this in Morphology software. Now, this Morphology software is the software we use for the GMM analysis for the 2D data that we perceived. The first step in this analysis, we performed the general Procussive analysis. In general Procussive analysis, what basically happens, it tends to reduce any kind of non-shape variation so that any size or any other factor does not come into the consideration when we are just considering the size. And it also tends to minimize the total sum of squares by translating, rotating, and rescaling each samples. So at the end, we get a particular kind of data, and that data is interpreted as principal component analysis. When principal component analysis is done, we automatically have a huge amount of data present through the general Procussive analysis. So what PC does is it tends to condense this form of data and help us to understand where actually the difference of variance lies, because it's expressed with a factor of eigenvalues and eigenvectors. So after this principal component analysis, we perform the discriminant function analysis, which helped us to come across the accuracy level, to classify the accuracy between the genders. And then we perform the Procussive Anova analysis, which helped us to calculate the measurement of error in the sample. So these were the 9 predefined landmarks that we used. So these were homologous landmarks. In all the sample, we marked the same spots. First landmark is nasion, anterior nasal spine, A point, B point, menton, gonion, chorion, sella, posterior nasal spine, as depicted in figure 1. Now coming to the result part, the first diagram shows us the general Procussive analysis across these limited centroid. And the second figure shows the principal component, each of these principal components with its collaborating variance. So it was seen that the first 10 PC showed 96% of the shape variance, of which first 3 had 58.3% of variance, in which PC1 accounted for 28.48%, PC2 accounted for 18.83%, and PC3 accounted for 11.06%. Also, these PCs were depicted in the lollipop graphs. These lollipop graphs I have shown in the latest slides. They showed that point B, menton, gonion, and porion in my study sample showed the most prominent variance among all the samples present. And these were the ones that help us to classify between the males and the females. So these were the charts, the graphs that I was talking about, these lollipop graphs. And then Procussive's Anova analysis was done, in which it was seen that the p-value was less than 0.001 with a high f-value of 11.84, thereby signifying that my study was statistically significant. Also, discriminant analysis was done, which correctly classified a net sample by 84% value, of which male were correctly classified into 83.3% and female to 86%. So finally, I would like to conclude by saying that this study of geometric morphometric analysis indicates it's important in using landmarks and multivariate analysis. Also, the higher classification success of this study can further be used in other kind of 2D as well as 3D study. The beautiful part about GMM is that it can be used in lateral cephalogram, it can be used in pictures, in multivariate studies. Also, within the same study, by expanding the sample size, can help us reduce, enhance the accuracy factor and also enhancing the classification success. Thank you.
Yeah, thank you, Dr. Shraddha. Very interesting study and very nicely planned study. So good to hear. Any questions?
What can I ask? Okay, Dr. Ivan, please ask.
No, please go on. I'll wait.
No, please. I'll take after you.
Okay, I just wanted to ask you, what do you think the correlation between the method you used would be with other methods that also try to assess sex by geomorphometric analysis? How many points would you think would be important to consider in order to increase the results of your estimation?
Yes, sir. So I feel the most important factor would be the landmark. The landmark which we choose is very crucial one in determining our results. Second thing, so the net sample size. Like the sample size makes a lot of difference if we calculate the PC or any other component that we try to went into. So if suppose 2 persons are doing the same study using GMM, but their set of landmarks are different, it will create difference in the study. If their set of sample size is different, that will also create a sample difference in the sample study, the result actually. So.
Thank you.
Any considerations for what kind of a population you used? Any kind of a consideration for the population used?
No, so in general, this was an Indian population-based study, sir. So there was nothing specific. I just wanted to keep it as pleasant occlusion and without any aberration, because it's a prima facie development thing, sir. So did not wanted to add much of complication to it.
Okay. You feel there'll be any change if instead of using a lateral digital Ceph, you use a primitive Ceph? Is there you expecting some changes? Because I still see a lot of tertiary centers having no facility of a digitalized one. Maybe a tracing sheet is being used, or a casual things are being used. Do you think there is some change in the?
So there would be because digitization would be difficult then. I feel like in the digital one, what we are doing is we are feeding it in a software and then digitizing the landmarks.
Advantage. What is the advantage of digitalizing? Why not use when there is no investment required? Maybe a 20,000 machine is going to do the job.
The analytical software won't be able to take the non-digitized landmarks. It works only on landmark coordinates. It works on X and Y coordinates.
All right. Excellent.
I think it would also reflect upon the reproducibility of the landmarks, as you're saying, right?
Right, ma'am.
Are there any landmarks which are more reproducible than the other ones, the ones who must have studied the literature?
I did not get you, ma'am.
Some landmarks which are easily traceable and which can, in inter-operator reproducibility is good in some landmarks and is not good in the other landmarks. Are there some?
Ma'am, the first 9 landmarks that are selected were the most trusted, reliable ones, which are being validated by a lot of articles for sex determination. So in that order, I did.
Which is the best one amongst the 9 which you used?
So Benton did show Gonion. Gonion was the most prominent one.
Fine.
Thanks.
Thank you. Great study.
Thank you.
Thank you, ma'am.
Okay. So the 7th poster today, ID is PS 121, Delaia Domenico, and he'll be talking about contribution of photogrammetry in the forensic analysis of human bite marks. PS 121.
It's okay?
Yes. We can see your screen.
Good morning, everybody. Good evening. Good afternoon.
Yes.
The title of my poster is Contribution of Photogrammetry in the Forensic Analysis of Human Bite Marks. The intraoral scanner is an innovative tool available in dentistry for taking impression for dental prosthetics and orthodontics. This device could also be a valuable tool in forensic odontology for the analysis of human bite marks. In this poster, a human bite mark was simulated on the arm of a volunteer. In this case, the volunteer is myself. And both the lesion and dentition were scanned using the intraoral scanner. I use in my clinical office a portable scanner to prepare files to be sent to dental laboratory for the construction of bridge and crown after the oral scan of patient. I occasionally bring this tool home. One day I was working at home with the scanner when suddenly my wife approached me and for no reason, I think, she bites my arm. Why? I don't know. Luckily, at the moment, she was not hungry. However, with great pain, I take a photo with smartphone using the comparison rule and scan the picture area in less than 30 seconds. Three-dimensional model, both positive and negative, immediately visible on the PC monitor, were obtained and 3D printout was performed later. I scanned the area also after 30 minutes, 1 hour and 2 hours. After these times, it is absolutely useless. The photographs and impression taken within 2 hours of the violence occurring allowed for the greatest detail of teeth marks. We know the forensic analysis of a possible human bite mark is strongly influenced by the quality of the evidence collection. So, it is particularly important to collect evidence as soon as possible, considering the healing process of the lesion and the elasticity of skin in a living person. However, the models obtained allowed, using software such as Paint, allowed a metric assessment of the lesion and the dentition, drawing lines and landmarks, contributing to the verification of the compatibility of the exclusion criteria. The use of contactless impression methods, such as the intraoral scanner, allow evidence collection of both images and impression without any alteration of the bitten area, which can also be subject of the saliva sampling. Three-dimensional models are one-to-one and bring indisputable advantages for analysis and comparison with the dentition of the suspects. To conclude, the intraoral scanner device, as I said, is portable, but also ergonomic, quick, easy to learn, and hygienic. The 3 and non-contact photogrammetry techniques are a valid tool for both forensic odontologists and emergency healthcare professionals in the event of child abuse or sexual abuse, contributing to reliable and effective collection of bite mark evidence. To finish with a smile, I understood why my wife action. That day, I wore the sweater given to my daughter for her birthday. This sweater. It's a finish, okay.
Thank you. Nice presentation. It actually made us all smile. So good presentation. Any questions?
I need you to switch off your screen sharing, Dalai.
Non ho capito. I don't understand.
You need
You
to
have
switch
stop
off.
share. Stop share.
Ah, stop.
Stop sharing your presentation, Domenico.
Se mi dici come fare, lo faccio. Ecco.
Yep.
Very good. I have one comment on your presentation. In your vision, do you think that every emergency department should have a scanner so that if there are lesions like this, they could real time have an impression of this lesion, which, as you said, is contactless?
All right. The lesion is important to take within 2 hours. The contactless is very important because there is the possibility to take the saliva, in this case, to discover the DNA of a possible subject of violence.
There is one question, if you allow me.
Yes, please go ahead.
Absolutely, sir.
So this was very interesting case, doctor. And do you think that with this help of the this scanner, we can make a 3D print also of that? Like cast, we make cast. So can we make that 3D print out with these help of these scanners? Is it possible?
The scanner of the scanner take with the scanner, intraoral scanner, it's possible to print every images in the PC, and with software of the paint can do the possibility to drawing lines, point, number, to comparison and effective T model of subject of violence aggressor.
Okay, thank you, doctor.
Doctor, I have a question. What kind of a scanner did you use? Whether it's an intraoral kind of scanner or a desktop scanner for scanning that particular lesion?
I use in this moment the scanner Trios, 3 shape of Trios. No last model, but there are 3 models, all very valid.
Okay. And did you face any kind of challenges while scanning the lesion?
I don't understand.
Did you find any kind of hurdles or challenges while scanning the bite mark or the lesion?
With the scanner, the lesion is don't touch the lesion with the scanner, because it's a work on 10 millimeters of the
The question
superficie.
is, Domenico, the question is it difficult or is it complicated to scan?
Absolutely no. It's quickly to learn. It's fast. All person can learn to use this tool. It's very easy.
Okay, thank you.
Okay.
Just one query. The only thing I think it is quite costly for using in a regular practice in all the healthcare centers in developing countries, right? Intraoral scanners are not cost effective, if you see. But otherwise, they are really accurate and they're being used regularly for the dental cast and preparing of the 3D models. So
As
yeah,
I see,
the only issue.
Surely. As I see, can those scanners of like Spider and those Altec and EPAC, those which are Russian and US based, which are used extraorally for scanning, which are I have a personal experience in that. I have never seen them using it intraorally. Do you suggest it can be used for intraoral?
Emilio, mi aiuti?
Dice la spesa, il costo dell'apparecchio lo rende ancora complicato nei paesi in via di sviluppo, però puoi rappresentare che si possono comprare di seconda mano.
Sì. It's possible buy several model of scanner. Obviously, all the model can find to a small money, but the quality is bad. The last model can find to 10,000, 50,000 euro. But this model is very performance.
All right. Thank you.
Nothing.
Right. Thank you. The next presentation, PS 123, is by Sanpreet Singh Sachdev, and the title is Characterizing Dental Traits with Phylogenetic Correlations in Reptilian and Mammalian Dentitions, a short study. PS 123.
A very good afternoon to one and all. Is the screen clear and my voice audible?
Absolutely. Please start.
Good afternoon to one and all present here. Today I'll be presenting findings of a short study that was conducted, and after analysis of dentition of various orders of reptiles and mammals, I'll be characterizing various dental traits present in their dentitions and terminologies associated with them, along with certain phylogenetic correlations that we could discern on the basis of these findings of our traits and terminologies. So the first question that might pop into one's mind, I am a dentist, so why do I need to actually study about animal dentitions? They are not of my concern. So we have all gathered here as scientists in the field of forensic odontology. So any science, any field of science that includes our forensic odontology science should never be restricted to an area. We should always seek for evolving. There is always a scope for evolution of the science. Restricting a science to a particular domain would eventually lead to its stagnation. So we should continually seek to evolve our field of science. And as it was presented earlier in this session very nicely, that paleodontology forms a very well integral part of our forensic odontology. Teeth are preserved for ages, and we could actually gain massive amounts of data by just observing teeth of fossils present. Apart from the historical aspect, coming to our present day world, we are not the only inhabitants of this planet. Along with us, there are animals also inhabiting, our fellow creatures inhabiting this planet. So every year, almost more than 4 million cases involving animal bites come in the court of law. And we should, teamwork makes dream work. We should collaborate with our veterinary dentists. However, when teeth are involved, it is imperative that we as forensic odontologists should have an understanding of these animal dentitions also. We should not completely ignore them. Understanding traits of animal dentition, their features, also gives us insight into their diet and social behavior, which I would be explaining in the subsequent slides. And linking these adaptations, we could even come up with evolutionary linkage present between them. So this was the basis on which I took up the study. For the study, 16 reptilian specimens consisting of testudines, that is turtles and tortoises, Lacertilia, that consists of lizards, Comata consisting of snakes, and Crocodilia consisting of crocodiles and alligators were included. As for the mammals, 44 specimens including rodents, canidae, Periso and Artiodactylae, and primates were taken. So a total of 60 specimens were included in the study. There, every order's respective photographs were taken in fixed settings of light and distance, and their radiographs were also obtained, although the settings were not standardized because there was varying bone density among orders and even among species of different orders. So we had to modify the exposure time for each order. Yet the radiographs, lateral cephalograms, and occlusal radiographs were taken. I'll be presenting the findings now. Okay. The first order I'll be discussing is testudines, that comprises of turtles and tortoises. Now, these animals do not have teeth per se. They have beak-like jaws with sharp ridges. So their diet primitively consists of hard-shelled creatures such as clams or snails or seashore creatures. One would think, without teeth, how are they able to crush such hard-shelled substances? So these, as you can see on this radiograph, the radiograph here shows us how much dense the bone is on the ridge. So a hinge-like motion crushes these clams, and they are subsequently able to swallow their prey and to tear off sea grasses. In tortoises, these ridges are also useful. But when coming to the teeth, that is seen in subsequent order of reptiles, that is comata or snakes. So these have multiple rows of teeth. As we can see in this picture, there are 4 rows of teeth present, palatine teeth present in the snake dentition. And these are very much similar to teeth found in fishes, multiple rows of teeth. So there could be an evolutionary linkage between these earlier reptiles and fishes. However, the teeth, as we see, are backward bending. So this is for grasping the prey and holding on to it. And eventually, if we see here, these are fangs present in a snake. These can be of 2 types, backward fangs and ones present in forward dentition, in front of the anterior region of dentition, that are called as forward fangs. So these are used to deliver venom while the snake holds on to its prey by means of these backward facing teeth. So anytime we need to disengage a snake or there's a bite mark, they would actually bite it by taking it front and then reverse way, and we have to take it out in front and then upward. That is how a bite mark would appear as a puncture mark for snake. Secondly, the next order is Lacertilia or lizards. The monitor lizard demonstrated in this order. Now we can see there's a prominent discrimination. The front teeth are incisiform and posterior teeth have developed some sort of conulates. So earliest evidence of conulates or triconodont teeth were seen in monitor lizards or earlier reptiles. Now their attachment, if we see, snakes had attachment superficially on the edge of the jaw. That is termed as acrodont. Only at the crest of alveolaris the teeth were attached. However, if we see in lizards, their teeth are attached to a buccal cortical plate only, not bilingually, but by means of only single cortical plate. This is termed as pluridont mode of attachment. Now the next order in reptiles is actually thecodont mode of attachment. That is, teeth were actually embedded in a socket as compared to only the buccal cortical plate. So this is the evolutionary phylogenetic linkage that we can establish throughout evolution of dentition of reptiles. Now these crocodiles as well as snakes and lizards all have this feature of homodontia. That is, all the teeth are similar in morphology, as well as polyphyodontia. That is, they continuously replace their teeth throughout their life. One set of teeth is lost, another replaces them throughout their life. So this was the order reptile. Now coming to earlier mammals, the order Rodentia is first considered, that included rats, rabbits, squirrels, and guinea pigs. So if we see their basic dentition, there's an incisor, there's a huge diastema, and then there are molar teeth. Now describing the incisors, they are orangish in color. Okay, the diet of rodents is actually low in calcium. So this iron was actually found to substitute calcium in calcium hydroxide. So this ferric hydroxide actually provides strength to the enamel. However, their teeth, if you see on this radiograph, they are huge roots present and they're continually growing throughout life. This continuously growing roots are termed as elodont, that is open rooted continuously growing teeth. So because of this elodont incisors, they have to constantly gnaw on something, which is why we find rodents troublesome. As a result of this gnawing and the enamel present only on the labial surface, this constant gnawing results in sharpening of incisors, that is termed as zygosis. So there's a labial preservation and a chisel-shaped incisor formation due to constant gnawing. And while the rodent tears its prey or flesh, it has to place it in this diastema while it runs to a safer place to consume it later. So furthermore, coming to the molars of rodents, they are actually not having cusp like a human dentition. They have prominent ridges that are termed as lophodonts. So these ridges are termed as lofts and the dentition is termed as lophodont. Now, if we see dentition of herbivores such as Artiodactyla and Perissodactyla, that includes horses, camels, boars, these also have a lophodont dentition. However, if we compare the lofts of rodents and herbivores, the ridges present in the herbivores, higher herbivores, are actually much more complex. They form a very complex pattern because of the coarse nature of their diet. So this gives us an insight of the diet of an animal. That is, it is an herbivore, although it is flattened, but the complex pattern means their food is very much coarse. Similarly, some rodents, grazing animals such as cows, do not have front teeth present. They have instead a thick gum pad, so with which they graze grasses instead
Last 1 minute, Doc.
tearing it.
Last 1 minute, Doc.
And similar to the elodont present, we can see hypsilodont teeth in these herbivorous animals. Lastly, apart from the herbivorous animals, we see carnivorous animals. Specifically, they have developed canines which are sharp. These sharp canines are indicators of male-to-male competition, as well as tearing through their flesh. The diet, carnivorous diet, there needs to be a scissoring action, which is termed as cecodont. Now, if we remember the triconodont seen in reptiles, the lizards, there is a development of basin in earlier mammals that is termed as talonid basin. And this basin later developed a separate cusp, which is seen in modern day Dryopithecus patterns seen in modern day apes. So this was the phylogenetic linkage we could establish from earlier reptiles up till the modern day ages. So to conclude, our knowledge should never, as a forensic odontologist, our knowledge should not be restricted to only human dentition. Instead, we should seek to evolve it to this relatively unexplored field of animal dentition. As we know, see, the one who has ventured into this field must be knowing. There's very less articles or very less studies related to animal dentition in the field of forensic odontology. So it is much difficult to find references to these studies. So there's a much greater scope, much horizons in this field that can be taken up. And as forensic odontologists, we should be standing in the forefront of such cases involving animal teeth rather than relying on veterinary. I thank the judges and respected audience for being patient. Thank you.
Thank you, Sanpreet. Very well presented.
Indeed,
we must. Yeah, please stop sharing. And indeed, it's very informative. It's good because animal bite marks are very commonly seen. So yes, it is definitely a part of something what we should know. So any judges? Any questions, sorry, from the judges?
I think Abraham will be coming because I could see first reference from him only.
Yes, like I did much work on the animal dentition as such. So as you had mentioned about the material method portion where you have incorporated dogs as well as equines. So what kind of, which all animals, like which all breeds did you incorporate in canines? Because we can see difference in the dentition there, even the classes of, when we talk about the skeletal and the dental occlusion. there is a difference in, if we talk about in pugs, in the Rottweilers, in like different breeds have their different classification. So whether it was in general or whether you have
Yes,
gone in depth.
as we saw, the specimens were not actually real specimens. They were museum specimens preserved over a period of 60 years. So there's no actual record of their species or breed. So in general, the characteristics of each order were discussed and the results were presented with phylogenetic linkage.
There is a one comment, please. Judges, I have one comment, please.
Yes, sir, please ask.
So, dear doctor, it is very relevant that we should study the teeth of the animals, because in the bite marks, the first thing which we have to do is that we have to rule out that these are not the animal bite marks.
Yes.
If these are not the animal bite marks, then only it comes to be a human bite marks, and then it becomes relevant. So it is the very first question in ruling out that the bites have not been caused by animals. So this is a very relevant thing, doctor. So of course we need to know more about this. Thank you.
Thank you, sir.
Okay.
Okay, so the next poster is PS 130 by Dr. C.H. Gyana Deepika. And the topic is dental age estimation using pulp tooth ratio of anterior teeth and institutional study. PS 130.
Hello, good afternoon, ma'am.
Yeah, good
Can't see
afternoon.
you. Can't see
Could
you.
you, can you please
Yes.
put on your video?
Yes.
And put on your video also? We can see this, you've started screen sharing.
Yeah, ma'am. Can you see me, ma'am?
Yes.
A very good afternoon, everyone. My research topic and title is age estimation, dental age estimation, and dental age estimation in our dental age estimation using tooth and pulp ratio of anterior teeth, and it is an institutional study. And introduction is age estimation of living individual is gaining importance, especially in cases of child labor and to assess disputed age in criminals. Previous studies on on adult age prediction in Indians have focused on histological parameters. They are invasive and they are not feasible in living individuals because ground sections and all has to be done. So we lose the actual tooth structure. So recently, the ratio of the tooth pulp area of was suggested by a group in Italy who developed a regression formula for age estimation. So my aim is to establish the dental age using pulp and tooth ratio of maxillary anterior teeth in an institutional study. It is an institutional study, and objectives is to assess the mandibular central incisor formula in relation to maxillary central incisor, and to establish a dental age formula for maxillary central incisors, because till now the whatever studies have been done are more based on mandibular incisors or premolars and canines, but not the maxillary central incisor. So we wanted to assess the maxillary formula. So we inclusion and excluded criteria. We included maxillary, right, and completely erupted tooth and teeth without any pathology, and we excluded periapical deep dental caries and fractures, attritions, and pulpar inflammatory conditions. So materials, intraoral periapical radiographs of maxillary anterior teeth collected from 35 individuals. They are between 20 to 60 years using a Paleo technique. Computer software GIMP 2.10.22 is used to calculate the pixel. And here the above picture is showing the IOPAR tooth. We have to take the outline of the tooth ratio and the pulp ratio. So the outline of both pulp and tooth area is drawn, and pulp tooth ratio is obtained from the histogram, which is tabulated here, and these values substituted in the lower incisor formula. So upper incisor formula is derived based on that pulp tooth ratio values. So and here this formula we have modified from the lower central incisor. So the variance is about 37%, and subsequently we have randomly selected 5 subsamples of 20 each from these exploratory samples, based on which the equation was derived. We have estimated using the general linear equation derived in the study. Age estimation from these subsamples are also done with the equation suggested for age estimation using lower sentences, which have consequently been using. This figure below is a graphical representation of the comparison of actual age with the estimated ages derived from upper central incisor based on the lower central incisor pulp tooth ratios. So this blue bar diagram is is derived from lower central incisor formula, and this orange one is the chronological age. So green bar is more derived from upper incisor formula, which we have derived, and these are more closer to the chronological age. That upper incisor formula is more closer to the chronological age. So our study is to test the variability of a tooth and pulp ratio of mandibular central incisor on maxillary anteriors in Indian population. Therefore, an equation for the maxillary central incisor was developed in the study. However, this was a pilot study, has yielded a variance in age by 87%. The best of our knowledge, this study is the first of its kind to evaluate the role of upper incisors in age estimation by using pulp tooth ratio in using IOPAR. So limitations is gender did not demonstrate a specific explanatory ability of the variance due to its small sample size. So I conclude by saying that this study gave much closer estimations of chronological age when compared to the pulp tooth ratio of lower central incisors. And these are my references. Thank you.
Thank you.
Please stop sharing.
Yeah, please stop sharing. Any questions for Dr. Deepika?
Could you please stop sharing?
Yes.
Okay, I've stopped it.
What do you think your results would be like when compared to other pulp tooth ratio methods with other teeth? You compare it only to the lower incisors. How about canines, premolars?
Because both tooth ratio and the pulp ratio differs from tooth to tooth. So lower incisor have lower dimensions. So the formula is for each tooth.
I think you did not comprehend the question.
Yeah, if you could please repeat.
Kindly repeat. We could not hear you.
Yeah, sir. Actually, every tooth has its own dimensions, that they differ in their dimensions. So the lower incisor formula is more, it's smaller. Like it is based on the dimensions of the lower incisors, but not on the maxillary. So we want to increase those areas, and based on the pulp and tooth ratio, we want to modify that formula.
I didn't read in the reference. There was an article by Cameriere 2013,
yes,
which was analyzing the same issue. Did you have a difference in your results?
They have used they did not use this formula, sir. That was using some paralleling techniques actually, but we have used software where we are calculating the pixel of the IOPR, and we are calculating, and they did not focus on maxillary central incisors, sir. Most of the studies are more on mandibular teeth, but not on the maxillary. So there, we did not find
any specific reasons why are we targeting the mandibular teeth? One, and secondly, as Dr. Emilio asked you, the Camry formula which you're saying is exactly using the pixels. They are exactly using the pixel pulp tooth ratio, but there is some difference between your method and his method. That's what Dr. Emilio wants to ask. What is the difference? One, and second is the question which I asked you. So both the questions you should address. Can't hear you. Can't hear you.
So you can hear me.
Yes, yes. Please go ahead.
So I don't know why they have focused more on mandibular teeth, sir, actually. But methods which I have used here is like it's a new software, but that is done maybe before 10 years. So
You mean the software which you used
is the latest
not
one.
like
Yeah.
as in you're using Adobe Photoshop? What you're using for pixel count?
I'm using GIMP software, sir. Which
GIMP is around 5-7 years old now.
It's a new version, and the pixel is also it's an
It is just a same thing which you're doing on Adobe. This is more used
we
because
can do yes, sir. We can use it on the Adobe also, sir.
This being no copyright, there is no download required. That's the reason we use JM. Otherwise, Adobe is good enough. It was good enough.
Actually, I think Dr. Kemry also uses ImageJ, which is
ImageJ
also
only.
available. Yeah, that's also freely available.
Anyways, thank you.
Calculating the pixel, we can, yeah.
Thank you.
Thank you.
Right, thanks. Our next presentation is PS134 by Vashishtha Singh, Identification of Charred Corpse by Dental Tissue, a Paradigm Shift. PS134.
Good afternoon, everyone. Is my screen visible?
Kindly wait.
Yes, your screen is visible. And we can hear you, so you can start.
Okay. It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. Good afternoon to one and all present here. My topic for today is identification of charred corpse by dental tissue, a paradigm shift. So what do we know about forensic odontology? It is a branch of dentistry that is primarily concerned with the use of teeth and oral structures for identification in a legal context. This discipline plays a significant role in incidents such as fires, tsunamis or floods, terrorist attacks, airplane crashes, train and road accidents, etc., where highly mutilated and dismembered bodies are recovered, which are beyond recognition. So, this process of identification of disaster victim is known as disaster victim management. Past data also suggests that fire remains one of the major causes of morbidity and mortality in the world, and identification of bodies from fatal fire remains a daunting task. So, our dental tissues are the hardest structures in the human body, as we all know, and they can be recovered in mass fatality incidents where other means of identification are destroyed or may be lost. Dental features such as tooth morphology, variation in shape, size, restorations, pathologies, missing teeth, and crowding, etc., gives every individual a unique identity. Coming on to the composition of teeth, teeth is mainly composed of about 45% of inorganic material, that is the hydroxyapatite, 33% of organic material, mainly the collagen, and 22% of water. Teeth can resist high temperatures, and discoloration of enamel and dentine starts after 200 degrees. They start becoming yellowish in color. Above 400 degrees, they become grayish brown in color, and above 600 degrees, they start becoming black in color. But above 900 degrees, they turn to porcelain white and become more brittle. This is how the temperature affects the teeth. Coming on to the identification, every tooth has a unique morphology, may it be the crown or root. In many cases, identification can be aided by restorations, dental implants, or orthodontic treatments. Implants have a very high melting point of about 1650 degrees Celsius, making it a helpful tool in identification. And now the dental tissue needs to be stabilized as well, because for analysis they need to be stabilized as they become fragile in cases of fire. Most popular methods for stabilization are polyvinyl acetate and cyanoacrylate glue, but various other methods can also be employed for this stabilization, which can be acrylic spray paint, hairsprays, or clear finger nail polish, and many more. But nowadays, one more method is also being used, that is 1 part of water with 1 part of black paste for stabilization as it is free of volatiles. coming on to the analysis, after stabilization, the incinerated dental remains are then sent for macroscopic examination, where color changes in the tooth are observed. As the temperature increases, the tooth color also changes, as I've told earlier. But it is different in deciduous teeth, as deciduous teeth have more of organic material present. Then we come on to the radiographic examination, where antemortem and postmortem intraoral, alveolar, and intraoral and extraoral radiographs are compared. In digital radiography, RVG is widely used techniques these days, but in cases of crime scenes, we prefer field radiography. Then the tissue is sent for SEM examination, which is scanning electron microscopic examination. It is used to analyze severely burned and fragmented teeth, as it allows sufficient magnification and distinct surface changes in the hard tissues. Lastly, we go on to the microscopic examination. We can see no microscopic changes up to the temperature of 200 degrees Celsius, but above that, up to 300 and 500 degrees, enamel and cementum start fissuring and fragmenting, and above 700 degrees, the dentinal tubules also start narrowing. But at the temperature of 1300 degrees Celsius, all the tissues of the tooth are lost. All the structures are lost. So all of these are then combined together and observed, and a forensic report is made. Finally, we see these pictures here. Some pictures are showing incinerated dental remains. Then 3D reconstruction can be used for reconstructing the lost structures, and X-Radioton EDEX 9900 and CamScan 2 are some of the novel developments in the field of forensic odontology for comparing antemortem and postmortem record of a missing person. Different temperatures have a varying effect on the teeth or enamel, dentine, and cementum, which can be observed under scanning electron microscopy. Radiographic examination can give information about the root morphology, bone integrity, restorative materials used, and making the identification process much easier for us. In the end, I would like to conclude by saying that the use of unique features and morphological variations of the teeth in personal identification is a well accepted task in forensic examination and in the court of law. Hence, forensic dentistry can play an indispensable tool in the process of human child corpse identification with positive results. These are my references. Thank you for your keen hearing.
Thank you. Any questions from the judges?
Doctor, you mentioned about certain stabilizing materials. So by using these materials, can you tell me that will there be any kind of change in the chemical composition of the specimens?
Sir, actually this that I told, cyanoacrylate and polyvinyl acetate, these are volatile. So they can produce some of the changes in the tooth. But the newer technique that I told about, this clad paste, one part of water and one part of glue with water, it is diluted form of that. It doesn't, it just produces a small, you can say, layer over the tooth. So there is no chemical changes in the chemical composition because of that.
Okay, and at what temperature you can find the fragmentation of the tooth?
So if the tooth structure, like anterior tooth, they are not well protected as like the posterior teeth, they are protected by the muscles. So in the anterior teeth, the fragmentation can be seen at lower temperatures, about 1100 degrees. The dentine enamel are totally fractured fragments you can observe microscopically.
Okay. And in your presentation, you mentioned the flow chart for the analysis. At the end, you are providing a forensic report. So you mentioned about the SEM analysis, SEM examination.
Yes,
so how are you going to prepare the samples for SEM analysis?
So the tissues, that dental tissues we are having, the charred tissues, we'll take those tissues and we'll stabilize first. Those tissues will be stabilized, then only we can conduct SEM examination.
Okay, thank you.
Okay, need to ask you, why were you so eager to stabilize it? What is the application of stabilizing it? Why do you want to stabilize it?
So before sending it for analysis, we need to then we take them due to put them in needs to publish them.
The 11th presentation today is PS 137, Paulo Henrique, and he'll be talking about the assessment of
Share my presentation.
Yes. Yes.
Is everyone listening me well?
Yes, absolutely.
Okay. Can I start?
Please start.
Okay. So good afternoon. I am Paulo Henrique Viana Pinto, PhD student at the University of São Paulo. And from now on, I will do my presentation titled Assessment of Ear Identification by Cameria's Method in Brazilian Sample. In forensic science, the identification of living people in crime scenes is an increasingly challenge due to the occurrence of social problems, such as theft and murder. In these situations, the only material that may be available for human identification are photos or surveillance camera images. In this context, the ear is described as a part of the body that may be helpful in the human identification of suspects. So the objective of this work was to test Cameria's method for ear identification in a Brazilian sample. This cross-sectional research was approved by the Research Ethics Committee. This was the protocol number. And all participants were invited and consented to participate. From the one, a convenience sample was formed by ear photos of 115 participants, of which 43 of them were male and 72 were female, aged between 18 and 60 years old. All of them were healthy and without malformations or trauma history or pathologies in the ears. The photos with shadows, blur, or distortions were excluded. To obtain the photos, a digital camera positioned at a distance of 2 meters from the ear of each participant was used, and both ears were photographed. Each participant was seated in a chair positioned in an environment with controlled lighting. To do the analysis, the software ImageG was used, and each photo was analyzed by 3 observers according to that method. Each ear was divided into 4 regions, as can be seen in figure 1. Helix, antihelix, concha, and lobe. Then area values to each of these regions were obtained. The data were organized in Microsoft Excel spreadsheets and submitted to statistical analysis. To do the calculations was used Python programming language. To access the inter-observer argument, Kendall's argument coefficient was applied. The proportions of the areas of each ear region were assessed using descriptive statistics. And to determine the similarity of the ear proportions for a given person, the Wilcoxon test was applied. Furthermore, to test the ability to identify a person based on the parameters of the ear, we used the key-dimensional 3 algorithm. Thus, with regard to the reproducibility of the method, an inter-observer argument was found to be high among all regions. In addition, the size in proportion in antihelix, concha, and lobe regions in both ears were similar, which demonstrates that these regions regions from Buffiers for him. However, the Alex was an exception, since this region showed a statistically significant difference between Buffiers. The evaluated parameters and the algorithm used allows a person to be identified by similarity between years on the same side, or the similarity of the most regions on opposite years, where the accuracy in identifying to identify a right ear based on the left ear increases accordingly with the number of suspects, as can be seen in figure 2. This means that in a practice viewpoint, when there is only one record of an ear of sufficient quality for comparison, the anti-Alex, conscious, and lobe regions from both ears of the suspect can be used for human identification, based on the assumption that there is a symmetry in those regions between both ears. Lastly, the parameters associated with the key-dimensional 3 algorithm were able to classify and group a set of ears based on the ear measurements. This is particularly important in crime scenes with lots of people or lots of suspects, since the method can be optimized the analysis. So it's possible to conclude that Camerari's method proved to be reproducible and useful for human identification in Brazilian sample. These are the references used in this presentation. I would like to thank everyone for your attention, and from now on, I'm available to judges for questions or suggestions.
Thank you. A very interesting presentation it was.
Could you please stop sharing? I've done that. No problem.
Yeah, you stop sharing.
Okay.
Yes. Any questions?
I have a question. Would you recommend the usage of intraoral scanner, like we've seen in the bite marks analysis just a few presentations ago? Or do you consider a standardized photo is well enough to provide an accurate identification, even in bite marks, perhaps?
Yeah. Okay. Thank you, Professor, for your question. We just use it standardized photos, not camera images.
Okay.
Thank you.
Right. Thank you, Paulo.
You're welcome.
Moving on. The next presentation is PS 138 by Doha Ambul Hija. And the title of the presentation is Mandibular Ramus as a Sex Predictor in Adult Jordanian Subjects. So PS 138.
Good afternoon, all, and I hope that you're all safe and well.
Yes. If you could just be a little bit louder.
Can you hear me now?
Yes.
Yeah. Okay. Good afternoon, you all, and I'm here to talk about my research, which is mandibular ramus as a sex predictor in adult Jordanian subjects. Human identification is an important part in criminal investigation and a way to express the respect of the legal rights of the dead. It can be performed by 2 techniques, either the comparative technique by comparing antemortem and postmortem records mainly of the 3 primary identifiers, which are according to the Interpol, the teeth, fingerprints, and DNA, or by constructing the biological profile by estimating age, stature, sex, and ancestry. Sex estimation is the classification, is classifying the individual as male or female, and it can be done by analyzing the skeleton as all bones found to have sex indicators. And it also is considered as the fundamental step in profiling, as most of age, stature, and ancestry estimation methodologies are sex-specific. Skeletally, the skull is the second most reliable skeletal sex predictor after the pelvis. And although the pelvis requires less experience in sex estimation, the skull is the most studied element in anthropology, as it's more preserved and can survive decomposition process. The mandible as part of the skull is the strongest bone of the skull and can be easily identified, even fragmented, and it has been extensively studied both by applying morphologic and metric methodologies. Sorry. We aimed in our study to explore the sex estimation of the human mandible using uncalibrated OPGs, and to do so by investigating the validity of the condylar angle, mandibular notch angle, and the error ratio between mandibular and ramus areas for sex dimorphism, and to build a regression model of sex prediction utilizing the significant factors. Our sample was composed of 50 LPGs of Jordanian subjects, equally distributed by sex, and for age mimicry, they were equally distributed by age, as we can see in this table. And only healthy adult individuals with known sex and nationality within the age range of 21 to 45 with absence of pathological or developmental diseases or syndromes that might affect the development or the growth of the mandible, and with absence of history of fractures in the mandible were included in this study. And the OPGs should be of a good quality, allowing us to assess all the anatomical features. And Jordan, for those of you who don't know, Jordan is an Arab country in the Middle East on the east bank of Jordan River, and was considered the largest refugee hosting country in the world in 2016. In our methodology, we've used ImageJ software to trace sex landmarks on each OPG, as seen in this figure, where A and F are the most superior point on the head of the left and right condyles, B, the deepest point of the left mandibular notch, C, the most superior point on the head of the left coronoid, D and E are left and right Guinean. Let's talk about our measurements. We've measured two areas as seen in this OPG. The first one is the orange one by joining the points A, D, and C, and the blue one by joining A, D, E, and F. And the two angles, the condylar angle, which is the angulation of the A, D line as seen on this cropped OPG, and the mandibular notch angle is A, B, C. And these golden lines are for tracing D, as to trace Guinean on the OPG. We've proposed this methodology by drawing a straight line from the intersection point of the tangent of the posterior border of the mandible and the lower border of the mandible that touches the mandible in point D. And we've performed a regression analysis using SPSS to assess the significance of these angles and the ratio between the two areas to overcome the magnification errors. Our results showed that both angles were statistically significant, whilst the area ratio showed no statistical significance in our sample. And the two angles were utilized to create a regression model using Excel spreadsheet. And this is the sex skull created by Excel sheet, in which the user has to type in the two angles and would give the probability of being male just to be standard, and the predicted sex, where if the probability is below, it gives the probability between 0 to 1. If it's below 0.5, it would give a predicted sex of female. If it's above 0.5%, it would give a predicted sex of male. And another 10 RPGs were assessed to assess the validity of the sex calculator, and 80% of them were sexed correctly. This sex calculator presented an overall accuracy of 77.6%, which lies between the accuracy range of 70 to 94% reported by previous studies for sex estimation using the mandible alone. And for the Jordanian population, this study presented an accuracy that's superior to two identified published studies, because it's not only superior to their results, but as well overcame their limitations, as the two studies used either morphological analysis, and so the other one used calibrated X-rays. And the area ratio presented no statistical significance in sex estimation, but the two areas can be tested on calibrated OPG, and this study needs to be validated as well on different populations on a larger sample size, and as well on different X-rays. And one thing I have to mention as well is the age range that was between 21 and 45. So the lower limit, the 21 was set according to the condylar cartilage development, which stops by the age of 21, and the 45 should be below 50, which is the age by when the age-related bone loss starts. And as well, it follows a Krugman statement that age sex estimation should be limited to the age range of 20 to 55 as well. Thank you. Just to conclude that this study presented the potential of the two proposed angles in sex estimation of Jordanian subjects. And as I mentioned, that it needs to be validated on different samples, dry samples, and as well larger samples as well. Thank you.
Thank you so much. Any questions from the judges? Okay, so let's move on. Our next and the final presentation for today's session is PS 120. This is by Shivani Basnet, and the topic of her presentation is instrumentation during dental autopsy.
Right, let me just share my screen. Is this visible?
Yes, absolutely.
Right. Good evening, everyone. My presentation is based on my research titled Instrumentation During Dental Autopsy, and my identification number, as mentioned, is PS 120. Well, let me start off with a brief background on how we came about carrying out this project. As we all know, dental autopsy includes dental examination, dental photography, and dental radiography. And these procedures, using equipment that help manipulate the dental remains, are carried out in more or less the same sequence as in a living patient. That being said, there are added difficulties we face due to peri and postmortem changes, and this demands a different approach in terms of technique than in a dental clinic. Now, these variations in techniques have been developed and perfected by forensic dentists over the many years. And however, the instruments that are used for dental autopsy procedures seems to have been stagnant over the past years. In relation, the guidelines that are available also do not address the availability or adaptability of the equipment to the challenges that are present. So the aim of this project was to understand the trend of the current use of instruments and guidelines followed by dentists, forensic dentists around the world during postmortem examination, and also to further design and suggest a list of instruments and a guideline for instrumentation. So a survey was designed using online surveys by JISC, and it consisted of 4 sections divided into 6 pages. There were a total of 14 questions, including 2 open-ended questions. The first section contained questions about the background of the participants in regards to their demographics, level of education, and work experience in years in the field of forensic odontology. The second section inquired about their work scenario during postmortem examination. Often forensic dentists consult at mortuaries, and the questions in the second section were whether they bring their own instruments or use the instruments provided by the mortuary itself, and also if they have any assistance or in the form of another forensic dentist, dental assistant, or a pathologist. The third section contained questions about the list of instruments that are used, the sterilization techniques, and the personal protective equipment that they use during the procedure, and the guidelines if they follow any. Now, this information was gathered for comparison to the suggested equipment and guidelines that are available in literature, and to know if the participants were aware about these. Now, the final section, the fourth section, included questions about any challenges that the participants came across during dental autopsies, and if in their opinion there are any suggestive solutions that could be followed by FOs around the world. The survey was distributed to 259 participants of 2 international organizations, AFOHR and Infodont, and the members of the British Association of Forensic Odontology. And it was live for a month from May 1st to June 1st of this year, following which the responses to the survey were analyzed qualitatively as well as quantitatively. The response rate for the survey was only about 24.8%, and majority of the participants were from UK, India, UAE, and Malaysia, amongst many others. All the participants had an academic background in the field with varying years of experience from 1 to more than 20 years. Importantly, we saw that there was almost an equal distribution between participants that were provided with as compared to those that brought their own instruments to work at the mortuaries. We also saw that 12% of the participants worked alone, whereas the rest had assistance in the form of another FO or a dental assistant. The most interesting findings of the survey have been shown in the graphs that will follow. In graph number 1, here, you can see the instruments that were most widely used as opposed to those that were least used by our participants. In terms of camera, the majority of the participants used DSLRs, but there were still few that mentioned mobile phones. The least used PPE included resistant closed shoes, heavy-duty rubber gloves, and particulate respirator masks, which I'm sure has changed due to the global pandemic. A major finding was the minimal use of resources and equipment that are already available, with only the mouth mirror, the ABFO number 2 scale, and the camera being the most popularly used equipment. The guidelines available from different organizations were also used only by less than half of the participants. In graph 2, we wanted to show the trend of use of guidelines cross-tabulated with the years of experience in the field. And interestingly, participants who had more than 10 years of experience have a higher rate than those with less than 10 years of experience of using the guidelines. This could either indicate less awareness or basically not using the guidelines due to other reasons. Finally, in graph 3, there are 3 pie charts that show challenges that are most commonly faced during dental autopsy. And it can be seen that majority of the participants say that they face difficulties during initial mouth opening in terms of visibility, that is illumination, and while taking radiographs. Other challenges that the participants have mentioned included keeping the oral cavity open, taking photographs, availability of instruments, and even the height of the mortuary table. Now, dental autopsy is based on a co-independent relationship between 3 factors: the deceased, the operator, and the equipment. And this balance can be affected by a variety of factors. And we're talking related to the equipment and resources, not related to the deceased or the operator. And the factors can include undesirability due to limited use and modifications, unavailability of instruments, unawareness of available resources, or even high cost of equipment. Participants suggested solutions like equipment modifications, communication and advertisement of different instruments and methods used by different FOs to solve these difficulties that are already available. Finally, a hope from this project was that it highlights the need for newer inventions and motivates the change that to the currently used resources. It not only gives us an overview of various challenges that are faced by the operators that need to be addressed, but also highlights that there is minimal use of resources that are already available, and hence a change should be prompted. To tackle the mentioned factors that result in decreased use of resources, a handbook that includes an overview of dental autopsy procedure and list of instruments that are used was designed and suggested as a reference for FOs, mortuaries, departments that want to provide these instruments. We're hoping to publish this work soon, and that it helps bring about a wave of innovations in the field. That is the end of my presentation with my references mentioned below. Thank you.
Thank you, Shivani. Can you stop sharing, please?
Yes, sure.
Thank you. Very well presented. Any questions?
Emilio, you can.
Yes, I would like to congratulate to this colleague for this topic. And I would like to just do a comment. At the University of Turin, we are working on a project related to dental autopsy. And if the colleague is available, I would like also to you to offer the opportunity of a joint, let's say, project related to dental autopsy. And I would just like to clarify also that there is actually although it is very useful, your research, in order to offer standards, universal standards, I have to highlight that there are already standards in the dental autopsy. You really need simply to address to books and read it. So, but beyond this, which is not a critics, I really like the content of the project, and I would like you to ask your team, your chief, the chance to do a joint research, widening the survey you did, because I think it should be added with digital and electronic devices, because we are all aware that nowadays most of us are using mobile phones to take pictures, because they are much with higher quality of the classic reflex or cameras. And I think that one of the questions, for example, would be if you are using a mobile phone to do pictures of the jaws, and which kind of device are you using for the X-rays, and eventually also the idea of taking or not impressions of jaws, and also the idea of using, as we saw in the previous presentation, scanners for the impression. So you have my address. If talk with your chief, and if they agree, if he or she agrees, I would like to do this joint project to widen the content. Thank you.
So thank you so much.
So there is one question, please.
Yes, sir.
So it was a nice presentation, but I will like to know that in your survey, how many were Indian participants, and how many were from the other countries?
Indian participants, as I can recall, we had 65 participants. Because of the pandemic, there was it had just started, so we didn't have a lot of participants per se, but amongst 64, we had almost 20 participants that were from India.
Mm-hmm. So what did you find that the presence of the instruments in the Indian mortuaries versus outside the country?
So it was almost similar, because as I said, there was a 50-50% distribution between those that brought their own instruments. So if dentists brought their own instruments to do the autopsies, they had availability of instruments. But if the mortuary was to provide, there was scarcity of instruments, not only just in India, but everywhere else too.
Okay, thank you. Because I was concerned mainly because there is in the mortuaries, there are very less instruments, even for the forensic pathology, what to say about the forensic odontology. So there are less number of instruments. So yes, if we can provide a set of the list of the instruments, probably then the Indian mortuaries that can go for that, and there will be less shortage of the instruments in the mortuaries. Thank you, doctor.
Okay. I would like to, that wouldn't be a comment, it will be more of a question and a highlight. I've just read across, Dr. Emilio, Dr. Hemlata just published an article on the SOPs which can be there on due to the COVID-19 attack, how mortuaries should be and what it should be. Any suggestions out of your study that, some modifications from the continuous regular mortuary setup, you want some changes to be happening now that the virus is so prevalent? And do you see any kind of a scope of, are there any references where the transfer has taken place? Because I could not find much of literature where their transfer has taken place from the mortuary, because we are spending so much of time and money on disposal of the dead. So do you think it is correct, or diverting so much of resources, or what do you say?
So I too have been keeping in touch with any articles that come up regarding this topic, and let me tell you, there are very few, and out of which mostly there's focus on the PPE and rather not on the instruments that we use. What I personally thought was, due to the pandemic and also due to the nature of the work that we do, disposable instruments can be made better, because I know there are a lot of complaints about how they break and they're weaker because of the plastic nature. And so I have been thinking about writing on this topic, bringing in disposable instruments, sturdier instruments, but at least to protect the forensic dentist, because obviously the deceased do not need to be protected from COVID.
Has there been an instance where they have the mortuary has acted like a nidus for spreading of infection? Has there been any reference with which you have come across?
No, sir, I have not.
One last question from my side. Doctor, whether because it's a questionnaire survey, so whether the questions were validated or by any peer forensic professionals, like just not the odontologist, because as Professor Rakesh Goria sir mentioned, more than odontologists, forensic professionals are in the mortuary doing the medical legal caseworks. So whether forensic medical professionals were involved to prepare the questions and to validate it. So any such?
So this was my postgraduate thesis. So I had two of my mentors were forensic odontologists, but apart from that, it was just three of us, team of three, and no one else. We did test it on my batchmates first, a test survey, and they gave us feedback. So we basically changed it according to their feedback, and that's it.
Since you are in the process of still making it, and you've already been invited to Turin, so I suggest you get it validated by a forensic medicine expert also, because they're going to take your life, because they'll make your life really miserable, because they are the people who are actually there in the mortuary. So
Right.
just take care of that.
Yes.
Yeah. Thank you so much. Doctor, before we put off today, I would like Dr. Priyanka to announce the result again, because there are teachers and there are faculty who are asking for the result to be announced again, because for some of them did not join. Dr. Ivan Bedek announced the result, but then I think right at the beginning there were people who were not there. So, Dr. Priyanka.
Well, it has been a well-spent Sunday, I think, and we've had amazing, enriching sessions in the morning, as well as afternoon was also a big highlight. I congratulate all the students. They have done just wonderful presentations, but we cannot announce the student results right now. We would still require some time because I will have to take the results from the judges, and then we'll have to compile, and then we'll disclose. So for the students, you will have to have some patience more, because we will be sending you the results by mail. As for the faculty results, which happened in the afternoon, the competition happened in the afternoon, and we had our esteemed judges, Dr. Rakesh Goria, Dr. Wendy, and Dr. Hemlata Pandey. and they had judged the morning session. The results were that the first prize, I'll go from the first prize first, and the first prize went to Dr. Anshul Chaudhary, PF 116. The title of the presentation was Simplicity in Application of Dental Age Estimation Chart, DAECC, by Dental Interns. The second was a tie, and the results were PF 114, Dr. Francisca Zangari. The title of the presentation was An Original Proposal in Dental Data Collection and Keeping to Enhance Human Identification. The second prize again shared by PF 101, Dr. Sandhya Tamgade, Modified Galileo Stain, its research applications in forensic odontology. The third was again a tie, PF 118, Dr. Kushali Joshi, Forensic Application of EDXRF to Identify the Gender from Saliva and Urine. PF 121, Dr. Kirti Chawla, Cold Laser Oral Therapeutic Device. So these were the results of the morning. And for the afternoon session, we will compile the results, and as soon as possible, we are going to mail to all the participants and association with us and for being patient. And, I think your presence definitely made all the difference